All right. So I think we are live. I see a couple folks joining us. Hi, everyone. Welcome. We'll probably get started in 60 seconds or so, but while you're here, please drop a note in the chat and tell us where you are calling in from and what you hope to hear about. Hey, Ronaldo. All right, this should be a pretty good turnout, I think. Hi, Chia. Welcome, Austin, Texas. It's a familiar town. Got a very exciting topic today, FedRAMP and Kubernetes. Montreal. Hey, Catalan. All right, well, let's jump into it. Pakistan, very cool. Hey, Mohammed. Thanks for joining. Let's jump into it. If you're here on time, then you get the benefit of hearing the introductory text, and if you're here late, then you'll just have to rewatch it. So thanks, everyone. Really appreciate you joining today. The topic of the webinar is going to be two exciting topics merged together: FedRAMP and Kubernetes, and we're going to really focus on the practical side of things. I'm joined today, very honored to be joined today by John Hamilton, Principal Engineer at Zscaler. John, welcome, and thank you for joining me.
Thank you for having me.
So the format of this is I'm going to do a intro to FedRAMP just at a very, very high level and try and set the context. And then as quickly as possible, we're going to get to the interesting part, which is a conversation with John, who's actually gone through this process and experienced the beauty and the suffering associated with getting FedRAMP authorization to operate on a Kubernetes system. But first, let's do a little bit of introduction here. Okay, so the topic is FedRAMP and Kubernetes. Let's talk about FedRAMP first. I'll be the first person to say I'm a FedRAMP newbie at best. There's other people at on the team at Buoyant who are experts in this. I only know the big picture, so that's kind of what I'm going to present today. So FedRAMP is an acronym for the Federal Risk and Authorization Management Program. There's a website, fedramp.gov, where you can learn all this and more. I think the takeaway here, if you're coming at this from kind of the Kubernetes platform engineer perspective, the takeaway here is that this is a U.S. federal government program, and it's a set of compliance kind of things you have to go through if you have a cloud product or cloud service that you want to sell to the federal government. Now, in reality, it might be wider scope than that, but that's usually kind of the starting point. We are a cloud provider. We have a service we're trying to provide, and we want to sell that to the government, or the government wants to buy it. Okay, great. Before they're allowed to do that, we have to get this authorization to operate. We have to go through this compliance process, and that's kind of like the heart of the matter, right? If you want this business, you have to play by the rules. So. The one thing I'll point out for folks who are joining now, thanks for joining. Great to see you. There is a Q&A kind of like panel off to the side. So at any point in here, if something we say is not clear or if it sparks a question in your mind, please do write something in the Q&A panel. We'll tackle it. We'll either tackle it in line or we might save it for the end, kind of depending on the nature of the question. So feel free to type something into that Q&A thing as we're going through this. Okay, so that's FedRAMP. Right, and if again, I'm kind of approaching this from the perspective of an engineer or maybe an ex-engineer. If you start going through this, reading through what is FedRAMP and what do I have to know, there's kind of this big set of vocabulary that's developed around this program. Not all this you really have to know, but if it's kind of helpful to give you a little bit of context. So, there's CSP is usually a term we're familiar with as engineers, right? You're the cloud service provider. In FedRAMP parlance, CSO is like the product that you're selling, right? And there's these various steps and entities that you have to interact with. One of them is this 3PAO, which really just means the auditors, right? It's a third-party assessment organization. These are the auditors that are blessed with the ability to perform like an assessment in the FedRAMP context. And then FedRAMP itself, this like government program, is kind of jointly operated by these two entities. There's the PMO, Program Management Office, which is the one that I think you will kind of interact with more directly if you are a CSP, right? And then there's the JAB, the Joint Authorization Board, which is doing a lot of the decision making. And then, as you're going through this process, one of the steps here is called the RAR, the Readiness Assessment Report. We'll talk about that in a minute. And then kind of the ultimate goal here, the thing that you're trying to achieve with FedRAMP is authorization to operate. So that's basically, that's the check mark, or that's the gold star. Okay, so once again, you're the CSP in this scenario. You have a CSO that you're trying to sell to the government. You're going to interact with, or someone in your organization is going to interact with an auditor called the 3PAO. All right, and then kind of your end result here, the goal that you're trying to achieve is ATO. All right, so hopefully that makes sense. Feel free to dump any questions to the Q&A channel or clarifications if you know more than me. And then, there's as you go through the FedRAMP process, and FedRAMP.gov has these lovely SVG images that like browsers can kind of half render correctly. There's kind of three basic stages, right? There's the first one, which just says FedRAMP ready, and then in this stage, your auditor has attested that you have these security capabilities, and you have this RAR. Remember, we talked about the RAR in the previous slide, that has been accepted by the PMO, right? Okay, so we already have a lot of these vocabulary words coming into play, right? So this is FedRAMP ready. You haven't, you haven't gone through steps 2 and 3, but your program is ready. It has been audited, and you have this RAR document that's been accepted. Okay. The second step is in process. So you're actively working towards authorization with an agency. This is a step in here where you have a federal agency in mind. So you have an actual buyer. In step 1, you're just kind of ready for action. Step 2 is you have an agency. And then the step 3 is you actually are authorized. You've completed, the process. And they have, if you go on FedRAMP.gov, they'll give you kind of like a little diagram of these are just the steps in getting to FedRAMP ready. So at the macro level, that's what this process looks like, right? And this applies to any software. It's not just Kubernetes. This is like any cloud software, I should say. If you are building software that is, designed to run on premises, and that's not a cloud offering, then FedRAMP is not really applicable to you. This is really primarily designed for, I have a cloud service. Okay, so we actually have, I think we have a fancy poll that's going to pop up, because the very first question, I was surprised by this answer. How many FedRAMP authorized cloud service offerings are there? So in the entire universe, how many have made it through this threshold? Does a poll automatically pop up, or do I have to press a button? I'm not sure. I think it's live. Yeah, it's open. Yeah. Okay. All right. We've got a couple of guesses in there. Is it 1 million? 100,000? 1,000? 100? 5? Is it just 5? I see someone guessed 3. Someone guessed 300. Okay. No one's guessing in the millions. Unsure. Someone put unsure. Okay. Well, thank you for your answer. All right. Let's see the answer. Ready? Everyone ready? How many FedRAMP authorized cloud service offerings are there? The answer is 309. So someone guessed 300. You were pretty close on that. Someone guessed 5,000. Oh, well, that's what I would have guessed, probably 50,000. So there's really just 300, and there's another 96 that are in process and 20 that are in the ready stage. So it really is, more rare than I think people expect, or certainly that I expected. Okay, there's a lot more to say about FedRAMP. There's many more nuances. There's different levels of FedRAMP, that I haven't touched on at all. But the kind of the basic process is what I described, right? You go through these 3 stages, and it's really applicable to, I've got a cloud service offering. I've got a cloud service that I'm trying to, sell to the government. Okay, so now, the point of this webinar, though, is not the FedRAMP explainer. The point is Kubernetes. If I have a Kubernetes platform or an application that runs on Kubernetes, what is specific to me about going through the FedRAMP process? Is there anything new or different or strange about that? Kubernetes, I gave a very brief overview of FedRAMP. I'm not going to give much of an overview of Kubernetes at all. Hopefully you understand what that is if you're here. Otherwise, there's a lot of learning ahead of you. I will point out, very important, it has 7 sides in that logo, so make sure you take that into account. I think the interesting thing from kind of the platform building perspective for Kubernetes, and I've talked about this in some other webinars at length, so I won't go too far into it. Kubernetes is designed to, it's like a Lego base plate, so it's designed to have a lot of pieces built on top of it, right? So when you're building a Kubernetes platform, it's not just, you're adding Kubernetes and everything, and you're done. You're taking Kubernetes and you're adding some kind of CI/CD system. You're adding, some kind of, you've got a code repo somewhere. You've got some kind of GitOps tooling, typically. You're potentially running it on multiple clouds. You're adding a service mesh, potentially. You're adding an ingress layer. You're maybe adding an egress layer. You're assembling these components into one big platform. And if you look at, I spent some time digging through the latest CNCF annual survey and kind of filtering it to the really mature organizations that have used Kubernetes at scale and over years. 100% of them were multi-project. And in fact, most of them used, or the average number of projects that they used was 20, like incredibly high, CNCF projects alone. So it's not even counting non-CNCF projects. 90% of them were multi-cluster, 75% were multi-cloud, right? So you end up with this very, very rich and complex environment. So when we say, hey, I'm using Kubernetes, that's shorthand for I'm using Kubernetes and a lot of other tools and a lot of other things. You have to take that all into account. And this is part of the fun. When we get to FedRAMP, you have to kind of take that all into account when you're describing your platform and you get the whole thing. You get the platform as a whole and the application as a whole authorized. Okay, so, oh yes, and here's like a picture of the CNCF landscape. This is a shock and awe diagram because I don't know if any human being, is really going to be able to parse through this. But here's a picture of every CNCF project. The graduated ones have like a bigger logo, and so on. Okay, so with that, we've kind of gone through the introductory section. Now we get on to the exciting and fun section. So we've talked about what FedRAMP is at a high level. We talked about what Kubernetes is at a high level. Now, the question that we're really here to address is, what does it look like if I am a Kubernetes platform owner and I have to go through the FedRAMP process? And so today, as I mentioned, we're very honored and flattered to be joined by John Hamilton, a principal engineer at Zscaler, who has gone through this very process, survived to tell the tale, and is here to share his lessons learned. So John, welcome. Thank you for joining us. Can you tell us a little bit about yourself, your background, how you got to be here today?
Sure. Thank you. Happy to be here. I'm a software developer, background on the application side, back-end developer. I started working with containerized applications around 2015 and with Kubernetes around 2018. I joined Zscaler a little over 2 years ago and joined the cloud browser isolation product group at a time when they were expanding their US team. Within Zscaler, that group is primarily in the EU, but they were expanding their US team with kind of an eye towards moving into deploying and supporting a federal authorized product or version of the product. So yeah, I came in because of my Kubernetes background, definitely not because of my compliance or FedRAMP background. That was all completely new to me. So
Right. Right. Okay, great. Well, yeah, so you started to answer this a little bit, but here you were, an innocent Kubernetes engineer walking down the street, and all of a sudden, you're kind of on the hook for this, this FedRAMP process. Can you tell a little bit about how that happened?
yeah, so fortunately it wasn't just like a surprise. I knew coming in that this was likely going to be my first project. And we had within Zscaler, the company as a whole already has products with an ATO, and so we integrate our browser isolation product integrates closely with those. So we had the, I guess, compliance advantage that we technically were coming in as, here's another acronym for you, an SCR. It's a significant change request to an existing ATO. My understanding is that makes the compliance side of things a little bit simpler. But from a technical standpoint, the world that I lived in, we still had to meet all the same requirements, the same controls. So yeah, that's how I came in. It was actually an interesting way to become familiar with the new product because we have to document everything. We need architecture diagrams to include in this SCR, and we need to know about all the data in flight, all the data at rest, and what actually makes up the product. So that was kind of my learning experience, was to learn every bit of the product, what the components are, how they talk to each other as part of this effort. So
How much of the product was documented by the time, at the point you entered the picture? Was it, all written up already, or did you have to develop a lot of that?
So we had a lot of architecture diagrams. I imagine I'm not alone in this experience, that things like that tend to become outdated almost as soon as you write them.
Yeah.
But everything was more kind of a logical, architecture layout of the major components and what they do and how they interact. And to get down to the level that we needed, mainly just to make sure that we're handling the in-flight data controls, the FIPS compliant encryption, which I'm sure we'll talk a lot more about in this discussion. To get down to that level of knowing like every single service and what talks to other service, with that level of detail wasn't documented.
Yeah, got it. Okay. Can you tell us a little bit about the actual product? You said it was browser isolation. What does that mean?
Yeah, it's browser isolation, cloud browser isolation. But it's essentially a browser that runs for a particular user in the cloud. Session happens when the user goes to visit a site that's been flagged for isolation via one of the Zscaler products that we integrate with. And so what happens then is the rendering of that website, the execution of all the JavaScript, all that happens in our isolated sandboxed environment. And what the user sees in their local browser on their computer is just the rendering, the image, so pixels, or it's like an interactive video of the web page. So that serves kind of two major use cases within the larger Zscaler ecosystem. One being the cyber threat protection. So, if you're browsing the public internet, it provides you that protection from potentially malicious websites without actually having to block the user and hurt their productivity. You can still allow them to browse websites that may not be known to be safe, but they're isolated, protected from any malicious JavaScript, things like that. The other side is data protection, where if you have your internal applications and you need to give access to a contractor or someone on the outside, you can do that without an agent by letting them access it through browser isolation, and you get more control over, like, limiting the ability to copy and paste, download files, things like that.
Got it. Okay, great. So that makes a ton of sense to me. And so the situation was you had, or Zscaler had, FedRAMP ATO for a separate product or suite of products. You had this new product, which was a browser isolation one, and you said CSR, you wanted to make a change to kind of that existing authorization to include the new browser isolation product. Is that accurate?
Yep. SCR, significant change. Yeah.
SCR, thank you. Okay. Okay. So you talked a little bit about the browser isolation product from kind of like the user benefit perspective. What about from the Kubernetes platform perspective? Was it, running on multiple clusters? Was it running in multiple clouds? Was it using all sorts of obscure Kubernetes features? Like, what did it look like from the kind of engineering perspective?
Yeah, so we pushed Kubernetes pretty far, I would say. The product is almost entirely in Kubernetes, and we have clusters globally. We have multiple clusters in some regions, and then within a given cluster, we're running at any given time thousands of pods. We've hit issues where we've run into the scaling limits of the Kubernetes control plane because of the number of pods we run. So as you can probably imagine from my description of the product, we have not only our your typical kind of multi-tenant workloads, but because we have to run these sandboxes, we have workloads that we run who exist solely to support a single user session. So they're there for a single user session. That's the extent of their lifespan. Then they get destroyed because we want to clean up that sandbox after it's done, and so that creates a lot of pods, a lot of churn, and it's a lot of pressure on the control plane.
Okay, so this was, in some ways, this was kind of a very modern Kubernetes deployment, multi-cloud, multi-cluster, but you were doing something that was, as you say, kind of stretching the boundaries of Kubernetes, which involved a lot of pod churn, basically.
Yeah.
Yeah, great. I am seeing some questions starting to go in the Q&A section, which is great. Please keep those going. It'd be great to have a couple of questions queued up, and then we'll tackle them. Okay, I think we might have covered this already. So why was it? Well, let's hear it from the source. Why was it so important for this suddenly to go for the browser isolation product to suddenly go through this whole FedRAMP process?
Yeah, so I mean, the product was already established, in our Zscaler commercial clouds as a commercial product, and it integrates with Zscaler Private Access and Zscaler Internet Access, and so those Zscaler products were already in Fed, had Fed customers, and those customers were asking for this feature. So,
yeah, great. So you weren't just doing it for fun.
No.
All right, so now we get into the gory details. What did the process look like from your perspective, kind of at the big picture level?
Yeah, so I benefited that Zscaler has their own internal compliance team who'd been through this before. So I worked very closely with them. Initially, it was me kind of meeting with them on like a weekly basis, and they were kind of guiding me on what the major boulders were that we needed to tackle to start looking at from the compliance side. And so the first thing that came up, and I imagine this is going to be the case for everybody, is the FIPS 140 validated encryption, and that was something that actually got more complicated between revisions of the FedRAMP requirements. So we came in under Rev 5, where those requirements got a little bit more strict to include all in-flight data and also any other crypto operations. So if you're signing a payload, or you're doing some hashing, even cryptographically significant random number generation, authentication, all of that now has to be done with a module that's FIPS 140 validated.
Yeah. Okay. Great. Let's talk about that a little bit. So you're saying one of the requirements for FedRAMP ATO that was kind of imposed upon you was that basically all cryptography in the system had to be done through FIPS validated modules. Now, FIPS is a separate standard that's kind of like incorporated into FedRAMP, and FIPS validated, as I understand it, means that the actual implementation, like the literal library, the binary bytes of the library have to be validated by a NIST certified lab. So it's not enough to say, oh, my algorithm is compliant with this NIST document. Like, it actually, the library version that you're using has to be certified by some NIST certified auditing company, as yes, we certify that this meets the NIST standards.
Yeah. FIPS-validated means you're not only using the set of algorithms that are approved by FIPS 140, but that your software module has been tested in a lab by NIST, and they've signed off on it. And there's a thing called CMVP. I think it's Crypto Module Validation Program, and they're on the NIST website, and they publish all of the validated modules.
Okay, so how did you handle that requirement? What were the set of options that you considered?
Yeah, so first of all, it was understanding where are we using crypto, and the first part was the in-flight data. I talked about building the map of all the data that's flying around, every network connection that we're making in our cluster. And so we looked at that. We knew pretty early on that we could cut off a chunk of this in one fell swoop with a service mesh and MTLS. And we knew that we were going to go commercial because we wanted the FIPS validated modules, the support, and it's always nice in compliance to have a third party to point the finger at. So yeah, we looked at commercial versions of Istio and of Linkerd. In our case, Linkerd was the way we went because it just worked. Like I said, we have some kind of unusual transitions between multi-tenant to single-tenant pods. We have cases where we're routing traffic to those single-tenant pods by their IP address, and Istio doesn't work just out of the box like that. So we would have had to make some changes to our code, some architectural changes, which we were trying to avoid if we could. And with Linkerd, when we did the POC, we were able to just turn it on, and it just worked. So that was we're able to get a lot further at the POC and get to the performance tests, which were also important to us, and it passed those as well.
Yeah, great. Of course, I'm very happy to hear that, and of course, I kind of knew the answer because this is how you and I started working together, in the first place, or I guess I should say how Buoyant and Zscaler started working together. But it's great to hear that. So you went through a process of we have to. We have an application today that maybe is doing some kind of cryptography, even in the sense of like, oh, it's making HTTPS calls or something to each other, to between services, or maybe not at all. You had to take that to the point where not only is it encrypting all data in transit, but it also is doing it with FIPS-validated modules. There maybe was a period of time where you were evaluating, do we use a service mesh versus not using a service mesh? You chose to use a service mesh, and then looking at all the options and evaluating them, you chose to use Linkerd, which is great. So that'll take care of kind of application, communication between different services, communication across clusters. What about there's other components of a Kubernetes environment. For example, there's webhooks, or there's bits of the ecosystem that talk to the Kubernetes API. Those all happen over TLS connections. Did those also have to be FIPS validated? Did you have to go through and kind of document and FIPSify every aspect of Kubernetes?
Yeah. So our approach was to be very low risk, both technical risk and compliance risk, and so we didn't want to leave any holes open that someone could point to and say, well, there's data in transit that's not covered. So
right.
The service mesh, that was probably 80% of the traffic, but then we still had to look at all the components we have that even third-party open source things that talk to the Kubernetes control plane. Well, the control plane is not included in the mesh, and we're we're in a public cloud, and we use some other resources from that public cloud. So there's APIs there that we have to call. That's egress coming out, and we have to authenticate with those services. So that involves computing a signature. So we had to look at all these other places that were using crypto, and those are the ones where we had to say, okay, well, how do we build these services so that they're using FIPS-validated modules, which was quite a learning experience. We did a little bit of purchasing of commercial builds of some open source tools, and then we got pretty good at building some things ourselves too.
Yeah. As someone who has been on the hook for ensuring we have proper FIPS validated builds of lots of cryptographic bits of software, it's not easy. It's not easy.
Yeah.
Okay, so you talked about, so we've talked about some of the kind of technical requirements, but you mentioned you had a Zscaler compliance team. Sorry, my camera is taking a very inopportune moment to put a little yellow box on my face. Don't worry, it's totally normal. What were the interactions with the compliance team like? Were they mostly pulling you? Were you pulling from them? What was the nature of the conversation? How technical were they, et cetera?
Yeah, it was definitely a really productive interaction with a lot of back and forth. Like I said, I kind of started out with weekly meetings to ask questions I had, for them to ask questions about our stuff. Initially, they were kind of guiding me, on what were the major pieces that that I needed to start focusing on from a technical standpoint. They're pretty technical, but they didn't have as much experience with Kubernetes and containerized workloads. So it was an opportunity to for me to educate them on how some of these things work, and in addition to them educating us on the what these different compliance things mean. Because within Zscaler, we were one of the first Kubernetes deployments to move into FedRAMP, and I believe we were the first under Rev 5, the newer requirements. So
I see. So you were like bleeding edge in terms of compliance.
Yeah. So there was a lot of collaboration with the compliance team on how do we satisfy this requirement.
Pushing the boundaries not just of Kubernetes but of FedRAMP.
Yeah.
Okay, we talked a little bit about Linkerd and the service mesh and FIPS compliant, or FIPS validated cryptography and things like that. Was there anything Kubernetes specific that made this, I said harder here, but maybe easier than it would have been otherwise?
Yeah. So definitely if you read the controls that are out there, they're not really written towards containerized workloads. There's a little bit of that. They're starting to catch up, but yeah, they're a bit behind on that. So some of these things, it was difficult to nail down. Even what does in-flight data mean? They're typically thinking of data, leaving a virtual machine or a node at the network card and traveling to some other node. But when you have pods talking sometimes on the same node, or containers talking within the same pod, it wasn't super clear on where to draw that line. We found some guidance that strongly supported that kind of pod to pod was the level that they would care about, that seemed to work through the audit, and that's how we got through. So that validates the whole sidecar approach and a lot of that. There's also things with, like, there's things called STIGs. Let me find my notes on what that stands for. But it's basically requirements that technical implementation guides for specific things. And so there's STIGs around operating systems. And so it's kind of like, well, a container runs a distribution. It might run a Linux distro, but it's not really running a whole operating system. So how do we map that STIG to a containerized workload? And then also, because it's Kubernetes, and it's containerized, and it's everybody gets to build their own service, to suit their needs the best. So we had many different container images and with different distros and stuff, and so making sure that they're all covered, they're all documented and FIPS compliant, and then managing the vulnerabilities and across a wide array of container images, I think, is a bit more complicated than some VMs that are all stamped out from the same image.
Yeah, got it. Okay, so kind of all the machinery, around Kubernetes that in some ways makes it, good as a platform, also makes it more complicated from the compliance standpoint, because they're not written with containerization in mind, with maybe they're written with virtualization in mind, but not with all the other kind of attributes. Was the compliance team, your compliance team, kind of helpful in doing some of that translation, or what was, how did you handle that, I guess?
Yeah, that was mostly something that I could kind of just talk to the compliance team about, and they would do some research and get back to me. They can navigate all the documentation on the government websites and find implementation guides and things like that have been put out that maybe aren't part of the controls, but can give some guidance. So.
Yeah. Okay, great. So we're approaching kind of the tail end of this. I guess I left the most open-ended question till the end, which is, are there any lessons you learned that you would want to, if you could go back in time, you could like tell yourself and save yourself some pain and suffering, or that you would want to share with others who are going to go through this process themselves?
Yeah, I've got a few things. I'll start with kind of the one I've been alluding to the whole time, which is to use your resources, use the rest of your team that's out there. We were beneficial. We were able to benefit from having an in-house compliance team, which helped a ton. But we also used our security team. They helped with doing threat models and some internal pen testing and providing guidance on that. And then all the engineering teams as well, the application teams, the operations, the infrastructure. It really touches everything. So it's important to not only get help but also communicate. Hey, we're working on this. This is why we're doing it, to get everyone on board. Like, here's why we're suddenly have to rebuild things to be in FIPS, or why we're asking you to take a more active role in remediating vulnerabilities and things like that. So that, but I don't want to just say, oh, use your compliance team that I was lucky to have, and you'll be fine. So on the technical side, I can give a few other bits of advice. We talked about FIPS a lot. That's definitely where you want to start. I think if you figure out your FIPS story first, and then you can kind of build other things around that, that's likely to have the biggest changes in your architecture. To that end, as a just a back-end developer who's used to like, oh, I import crypto TLS and go with it without thinking about what module is being used, I had a ton of information, just kind of knowledge gaps that I didn't have coming into it, that I needed to understand before I could even do the right Google searches to figure out how do I build my application to be FIPS validated. And so there's a lot there to learn. I ended up writing a internal wiki to help the rest of the team that kind of walks through where crypto happens, whether it's in the kernel or dynamically linked libraries, statically linked libraries, and then a few guides, which will probably become outdated quickly, but a few guides for different programming languages, how what some approaches are, what some modules are you can use, and how you can integrate those. So I wrote that internally. Zscaler was kind enough to let me make that an external post. I haven't put it up yet, but I'll be getting it up on my LinkedIn by tomorrow. So hopefully we can share that link out, and that won't give you everything you need, but hopefully fill in, if you're like me, fill in that background knowledge that you need to do some more intelligent searches. So the FIPS is a big part.
So everyone follow John Hamilton on LinkedIn, so you get a notification and bump his follower count.
Yeah, follow me for that link. I'm not super active on the socials, as the kids say. But yeah, and then another goal that we started out with this internally. I think it was a great idea. Was we set out that we're going to have zero drift between our commercial and our Fed environment. So whatever architectural changes we make, or changes to our build process or deployment process that we make to support Fed, we're going to do in commercial as far as we can. Ultimately, there's things you hide behind feature flags that you can't enable in Fed because they integrate with something else that's not FedRAMP compliant. But if we start out with that goal, then I think you're going to be much better off not having to maintain, different branches of your code for Fed versus commercial, and just all the extra overhead of that. And then lastly, I mentioned we're very risk averse, and I mentioned the two types of risk, and trying to balance, your technical risk versus your compliance risk. And so, sometimes you want to avoid making major changes to your architecture because that's going to introduce technical risk. But there may be other cases where it's better to pay that up front versus risking running into issues with compliance. And I think we struck that balance pretty well. And I said last one, but I do have one more, and that's don't sleep on the what they call ConMon, continuous monitoring. That's technically seems pretty trivial. You just need to deploy and be constantly producing an inventory, scanning it for vulnerabilities, doing that sorts of thing. But then you're on the hook for actually fixing the things that it finds. So be proactive about how are you going to fix critical CVEs within 30 days, and what that process is going to look like.
And that ConMon term is like that's what the FedRAMP people call it, or is that a Zscaler term?
That's what FedRAMP people call it. I think it's not a Zscaler term. It's at least so one that I've heard outside of Zscaler. So.
Okay, great. So, folks, we're at the tail end of the webinar. Now's your last chance to type in any questions that you have for John. We're very privileged to have him today. He's a tremendous resource for, everything FedRAMP related. And well, I should say everything FedRAMP and Kubernetes related. So please make use of it if you can. We have, follow him on LinkedIn. Obviously, you'll get a pointer to the doc that he's writing up, which I think will be a really, really invaluable resource. We also have, if you're joining us live, we have a handouts section to the side with a couple white papers from Buoyant about FedRAMP and how we've helped companies like Zscaler tackle this, especially around the FIPS-validated encryption of data in transit. John, there is one question from Chris. Says the cloud browser isolation, is that similar to Apache Guacamole or to Kasm, Kasm?
Yeah, so I think Kasm and Guacamole, they're both sort of like remote desktop tools, and so you could say they're similar in that they're streaming pixels and allowing interaction with something that's running somewhere else. In our case, it's completely agentless, and it's focused on a browser, and then we have tooling around the browser that will allow things like copy and paste through if you need to, and file upload, download, and integration with Zscaler's sandboxing and other things like that. So.
Yeah, great. Okay, and another question. So thank you, John. Another question from Chris. Gold star to you, Chris, for 2 questions. I'm sorry, I pressed the wrong button. Have you evaluated using OSCAL in concert with continuous monitoring for FedRAMP?
So I'm Googling OSCAL. So we
Same.
Is that what OpenSCAP uses? Because we are using OpenSCAP for scanning our images, and we ended up moving our base images to Wolfie, which is like a kind of a distroless and undistro based image. There's a company ChainGuard that developed that, and we purchased some of their FIPS builds, but they also provide, I'm guessing it's a OSCAL if that's the relationship there, but it's a specification that tells OpenSCAP how to scan the images to make sure they're compliant with STIGs. So we did do that.
Awesome. Well, John, thank you. We're right at the very final 60 seconds of this webinar. If you're joining us live, you'll see an opportunity to have kind of a follow-up conversation. Sadly, not with John, although I would love to rope him into that, but with someone at the Buoyant team. If you are tackling FedRAMP for your Kubernetes platform, or you're going to be tackling that in the next couple months, I would encourage you to click yes, and let's get that conversation started now. Otherwise, circle back when you're ready for that. John, I did want to thank you so much for joining us today. Really appreciate your time and your hard-won lessons shared with everyone here. So thank you very much.
Of course, thank you. This is fun. Hope it was helpful. Yeah, and happy FedRAMP Kubernetesing.
Yeah, that's right. And best of luck. All right, everyone. Thank you for joining us. Please click that blue button or come visit us at buoyant.io if you are tackling the challenge of FedRAMP and Kubernetes. We will do our best to help you along that process. You can end up with a smile on your face, just like John here today. And John, thank you again for your time.
Sure. Thank you.
Bye, folks.
Bye.